Alrighty, so I'm hoping if you're watching this, you've also seen the video on scientific notation, because as I mentioned in that, these two go hand in hand together. But significant figures essentially is a way that we round very small or very big numbers. So if I've got a number like this, 23.6158, and let's say this is some monetary value. Well, I might round that to 2 decimal places. And I might say that is $23.62. And that's an easy way. We round that to 2 decimal places. But what if I've got something like $23,615? Okay, and I want to round that. Well, there's no point in me rounding that to decimal places because it's already rounded to the nearest whole number. But if I want to round that using what we call significant figures, I might want to turn around and say, well, that's approximately $23,600. I might turn around and say it's approximately, by the way, this equal sign with the dot above and below just means approximately equal to. I might turn around and say that's approximately equal to just $24,000. Because, of course, this 600 means I would round up to 24,000 rather than leaving it as 23. So what I'm saying here, this is 3 significant figures. Whereas this one is only 2 significant figures. Now, what a significant figure means is that if I am rounding this number here, what I'm saying, these $15 relative to these 23,000 or these 23,600, depending on how we want to round it, they are less significant. So what we do is we are making some judgment or observation and saying, I'm going to round to a certain number of significant figures, and everything after that is less significant because it is of less value. So here I would say that I've got 3 numbers, 1, 2, 3, that are non-zeros. We'll get to the idea of that non-zero in a minute, but I hope what you can see is I've really taken the first 3 digits here, and then I've put down 2 zeros. We wouldn't just write 236 because that would be the wrong value. It is still $23,000. So even though we have cut off the 1 and the 5 that we say are insignificant, we still need to represent those as zeros when we're dealing with very large numbers. The same applies here when I've got 3 zeros. And I'm representing that 6 and the 1 and the 5 as zeros there as well, because we say they are less significant. Okay, so what if I've got something like a very small number? Okay, so I've got 0.000150 and I'm going to put that into a certain number of significant figures. Well, again, if I rounded that to 2 decimal places, I get 0. 3 decimal places, I get 0. So there's no point actually here me saying let's round it to a given number of decimal places. So what significant figures really does is it takes the size of the number out of consideration. If we're looking for 3 significant figures, that doesn't matter whether we're dealing with 35 million or 35 divided by a million. We'll end up with the same number of significant figures, or same number of digits in our answer. So here, if we're looking to go to 3 significant figures, okay, well I would say I would just keep scanning across, starting from here in this direction, and look for my first non-zero. So that is my first significant figure. So I'm going to go down and put 0.000, and then I look and I'd say 1, 5. Now, of course, we round as we normally do. So I'd look at those 2 digits and I'd say, okay, so 2 is less than 5, so I'm going to leave that as it is. Now, in this case, I still need that third significant figure, which happens to be a 0. I still include that 0 because that is my third significant figure. If I was only after two significant figures, well then I wouldn't put any more zeros. Okay, these zeros here are really there to make sure that my number still has the correct value. What we're saying is that 0 at the end is still a significant figure. That is my third significant figure. Now, if we wanted to combine this idea of significant figures with scientific notation, it's the same thing. It is literally a merging of those two ideas. I would, again, write down my first non-zero, being 1. Then I would write my decimal point. My next two figures are 5 and 0. As I just mentioned, keep that 0 there. Multiply by 10 to the power of, we know it's going to be a negative power because it's very small. I jump 1, 2, 3, 4 places, so it's 10 to the minus 4. Now this answer here is to three significant figures, sometimes represented as SF or sig fig, in scientific notation. Okay, so that is our idea here. That's where we're looking to get to, being able to write this in scientific notation using a given number of significant figures. As we said before, rounding to a certain number of decimal places for really large or really big or really small numbers, not actually terribly helpful. So we need to actually take the size of the number out of the equation and make it more about how many numbers I'm actually going to include.